A regular old boring trapezoid has one set parallel sides. Has one set of parallel sides. That's it. Oh. It only has one set of parallel sides. Those sides don't have to be congruent. And I know you've all seen pictures of these before. This isn't going to be anything outlandish. That's a trapezoid. I know you've all seen it. There you go. So trapezoids just have one set of parallel sides. It just has one set of parallel sides. It can be anything. As long as it's only one set of parallel sides, it's a trapezoid. Yeah. That's a fancier trapezoid. So what you're drawing is the fancier trapezoid. The fancier trapezoid is the isosceles trapezoid. The isosceles trapezoid is the fancier of the two, the one you're more accustomed to seeing. The isosceles trapezoid follows the rules of the trapezoid by having just one set of parallel sides, but it also has congruent legs. So the isosceles trapezoid has the one set of parallel sides and congruent legs. Now, I'm assuming you guys are okay with me calling those parts legs, because they're kind of fit the role of, you think about it, like a triangle. When we had isosceles triangles, they had legs, they had base angles. Well, with the trapezoid, they've got the congruent legs still have base angles. The base angles here, they have two sets. And both sets of base angles are congruent to each other. So they have two sets of congruent base angles. And obviously, you think about it, these are two parallel lines cut by a transversal. One of each set will always be supplementary. Okay. The base angles that are next to each other, the base angles that are between the two parallel lines are always supplementary. The parallel lines are always supplementary. Supplementary means they add to how much again? And there's one other part to these that I always seem to forget, but I remembered because I forgot second hour, so remember today. Isosceles trapezoids have congruent diagonals. So regular trapezoids are just one set of parallel sides. Isosceles trapezoids have a whole bunch of other stuff with them. When you have a non-isosceles trapezoid, just so you remember, when you have a non-isosceles trapezoid, these two angles here are still supplementary. These two angles here are still supplementary, but they're just not going to be congruent across from them. Does that make sense? Because you still have two parallel lines cut by transversal here and here. So the angles between the parallels will always be something. That's so bad. Okay. Doesn't do anything about the angles. It's just they're there. Which means that you have one other part to them. We have what are called midsegments, and you've seen this. Trapezoids have midsegments, just like triangles have midsegments. Triangles had midsegments in chapter 5. Midsegments were the segments that connected what's of the sides. Midsegments connected the what's of the sides of a triangle. Midpoints. Convenient that it has the word mid in it. So trapezoids have that too. When you have a trapezoid, I'll just press the button, draw a nicer. When you have a trapezoid, these guys are always parallel. If I draw it like that, is that an isosceles trapezoid or a non-isosceles trapezoid? Non. That picture right there is non because look at how the tick marks are. See how one of them, the one segment has one tick mark, the other one has double, double? That means that those two aren't all the same. If it was an isosceles, these would have been all the same. Does that make sense? It's just drawn differently. I'm just trying to show you that it works for both types. Thank you. So within mid segments, excuse me, within mid segments, you have, with trapezoids, it still connects to those midpoints. It's parallel to the two bases, and it's equal to half the sum. So mid-segment is parallel to the bases. When we talk about the bases here, the bases in the trapezoids are always the ones that are parallel. I'm guessing you probably knew that, but make sure I say that. You okay? All right, so it's parallel to the other bases, and then it's also equal to the average. So the mid-segment equals half the sum of bases. Okay. It's the exact same formula that we use with mid-segments with triangles. It's equal. The triangles one is equal to half the side it didn't touch. With these, they're equal to half the sum. And you've seen this before as well. Whenever we wrote stuff out like that, if we said that the mid-segment is half the sum of the bases, instead of multiplying something by a half, instead of taking half of something, what do we do with that half to move it to the other side? If you divide it by a half, then you're multiplying by its reciprocal. Yeah. The other way of writing that out would be if you double the mid-segment, it equals the sum of the bases. Okay. The algebra we're working through here should not be very. The only other thing you'll wind up with a lot of times with these is that you'll get a bunch of corresponding angles and things like that. You won't have, I won't have much else than that, but for the most part, that's really all we write up. Let's try a couple problems. Take a second, see if we can figure out what to do here. So just by the diagram, that segment QR is connecting midpoints, which means it has to be what we call that mid segment. And like we've done so many other times throughout the semester, I always like to write down formulas of what things are before I try to do any of the work. It helps you be able to figure out where things are going to go, what parts get substituted to what. So I know that I have the mid segment is half the sum of the bases. That B1, B2, B sub 1, B sub 2 technically, does it matter which one's which? Oh, doesn't matter at all. Which one of those three is the mid segment? The middle one. Thanks, Captain Obvious. So yeah, just put in substitute in the x plus 2. It's half of and now it's just a matter of simplifying out. You have 4x minus 10 plus 8. Combine terms in there. In this case, can I just take half of 4 and half of 2? Or do I want to multiply the other side by 2? It doesn't matter. It doesn't matter. I would just take half of the stuff in the parentheses because both numbers in the parentheses are even. Half of even numbers are nice. What's half of 4? And what's half of 2? Remember, you have to go to both parts. Sometimes you guys forget that. So you get x plus 2 is 2x minus 1. And lo and behold, we're back to a very quick problem. Subtract x, add 1. You get 3. Now, that shows you how to go back and forth between these. So if you substitute in here, this becomes 5. And then the other part becomes 2. And to know if you're doing it correctly, well, from 8 to 5, do you go up or down? How many? What's 3 less than 5? And we mapped correctly. We've done this exact same problem in about 3 or 4 different sections. Remember when we did midpoints, where we did find the missing endpoint? You had an endpoint and a midpoint, and you had to find the other part. We did it then, just by counting. Do the kind of same thing here as well, just to make sure everything works. So the idea of working with these midpoints and mid segments kind of shows up throughout the whole semester. All right, you do this one. That's a mid segment again. Take a second. Figure out what W, Z, and TU are. It says solve for X, but I want you to find the segments as well. Please. Okay. Oh, figure out both the missing segments. Oh. Just to substitute in, because it's one of those things that sometimes I'll ask you to find the missing segments, sometimes I'll ask you to solve for that. So figure just by doing it both, you just get the practice at it. Okay. I mean, like I was saying earlier, it's not that terrible. I hope. Dryness in my hair is killing me. That's poetic-ish. Which one's the mid segment? Move that over. Half of 6x minus 12 plus 18. Combine your stuff in the parentheses. You know what? 6x minus 6, or sorry, 6x plus 6. Thanks. Do I want to double everything, or do I just want to take half of the 6? Yeah. Again, it's not so bad. You don't have to worry about it because it works out clean, or cleanly, I should say. Subtract the 2x, subtract the 3, you get x is. So if x is 7 and you substitute back in, what's 2 times 7? Add 10, you get? Right. 6 times 7 is 42. Subtract the 12 and you get? 30. And again, it's super easy to tell whether or not you mathed correctly because going from 30 to 24, do you go up or down? How many? What's 6 less than 24? Great singer. No. Yeah, look, it's cold out. All right. So you can figure this one out. Now, that DE is a mid-segment, and they're saying that it's an isosceles triangle, so they'll be put together in a couple different parts. So you can figure that one out. A little trickier. He's basically. This angle is 32. What are your base angles at B and C? What are the base angles equal at B and C? They're both 74. You guys okay with that? Reason they wind up... Guys, remember, this is an isosceles triangle, so these two guys have to be the same. Start with the 180. Start at your 180. Back out the 32. When you back out the 32, you're left with 148. Angles B and C have to be the same because they're base angles of an isosceles triangle. So you take that 148 and cut it in half. We get 74. Those are both 74. It told you that DE and BC were parallel to one another, which makes that segment AB a transversal. So angle B is 74 degrees, which means as you come up to this side here, also has to be 74 degrees, which makes these, or excuse me, the other side, its supplement, which is 106. Okay. And that's how that works. When you have the reason that you get what are called isosceles trapezoids, the reason that they're created is quite literally from the midpoints of an isosceles triangle. They have to be there. Because if these guys are the same, these are the same, makes these the same, makes those the same. That's how they're created. Okay. Let's talk about kites then. If you want to go outside right now and try, go for it. I'm going to go ahead and say no, not a great idea. Yeah, I'm going to go out and say no. So kites. Kites actually have quite a bit going on. And it took me forever to figure out the easiest way to draw these. I think it was Mr. Gonzalez that showed me. Just make like a cross and connect the outer edges. But that's kind of, I have never been able to freehand a kite to save my life. I just can't. I don't know. Never been. I tried. Well, I just did there, but I used to be really bad. I got better. So properties. Kites are basically made up. You all right? Yeah. Kites are made up of two isosceles triangles that share the same base. Kites are just two isosceles triangles that share the same base. Okay. Which means they have two sets of non-opposite sides congruent. And like I said, think of it in terms of two isosceles triangles. They have diagonals that are perpendicular. And now is when it starts to get kind of weird. If you look at it in terms of two separate isosceles triangles, it's kind of easy to see how this gets developed. If I cover up the bottom part here real quick, and I look at it in terms of an isosceles triangle. The isosceles triangle has congruent legs, which means it has congruent base angles. Okay with that? So what I would do is I would mark these two here. And then, do you also agree that I have a reflexive side for that vertical part? Yeah. So what we wind up with is angle, angle, side. You get two congruent triangles built out of the isosceles triangle. And we've done this before when we did the isosceles triangle. Can we please put that away and not play around with it all the time so this is all over and annoy everybody? Okay. So once you get the two triangles that are congruent, you can go back and go do all the corresponding parts. Which means that the only things that aren't marked there are these two parts here. That segment, that diagonal of the kite, is bisected. And this angle up top is also bisected. Okay. And it does the exact same thing on the bottom. The angle down here is bisected. These two angles aren't congruent. So kites have a lot of stuff going on because they're just two isosceles triangles put together. Yeah. Okay. So I think the easiest way to list it out is the diagonal between the two sets of congruent sides is bisected. That's this guy here between the two sides. That one's always bisected. The other diagonal, and so the angles between the congruent sides are bisected. That's at the peaks for where the two isosceles portions are at. And then the only other weird thing that there is, if there can't be more, is think of it in terms, it's kind of easy to show you this in terms if I throw numbers at it. If I say that this angle here is 40 degrees, what does this one have to be? 40. If I say that this angle here is 70, what does that one have to be? 70. What's 40 plus 70? What's 40 plus 70? Now, what's going to happen here is that those two angles, the two angles that are always between the two sides that aren't congruent, those two bigger angles will always be congruent. Because no matter what this one is, that's going to be the same. No matter what this one is, that's going to be the same. When you add two things together that are the same on both sides, you're always going to get the same number unless you don't know how to add. It's just possible it happens. But the angles between non-congruent sides are congruent. Okay. There's a lot going on in one of these. It's not tough, and a lot of times you'll be able to figure it out rather quickly. And I think the worst thing that you'll see with one of these is that you might have to use a Pythagorean theorem. Because if you look at the kite, you have 4 right triangles there. What we used to have to do, when this was the second semester thing, we would use a lot of trigonometry to figure out missing sides and missing angles with sine, cosines, and tangents and stuff like that. But obviously we're not there, so we can't do that. Yeah. Let's try it. So if these guys are kites, find the missing angles. Find the missing angles. Okay, take a couple minutes and see if you can figure it out. Please and thank you. So the first one's pretty easy. Angle M is between the 2 sets of congruent sides, which means angle K has to be 88. Okay. Now, these guys are quadrilaterals, which means they have how many sides? Which means they have how many angles? 4 of them, which means what do they all have to add up to equal? 360. So it goes back to the idea that you have your angle sum. So to figure out the total, take 360, back out to 120. There's your 240. 88 and 88 is what? 176. And then what? 64, I believe, the top one. You're nodding yes, so that's good. Okay. Huh? Something hiding in it? No. What's wrong, Marissa? Flatting out. Same thing here. In this one, you're trying to figure out M and K. These guys are going to be the same angle, aren't they? Yeah. So what's 50 and 60? 110. So we take 360, back out to 110. What are you left with? 250. To figure out what those both are going to be, you just cut that in half, which is good, very good. You get 125. So even though the kites have 1,000, well, they have a lot of properties, you're only using really one of them or so at a time. What did I do wrong? You all right? All of a sudden you just went cross-eyed. I was like, oh. Oh no, algebra, what do you do? Do you have to do that? Why would you do all that work? If I just need to solve for x, what do I set that equal to? 111, right. Aren't these two angles supposed to be equal to each other? Oh, I got you. All right. Well, let's worry about this one first. How do you solve for x? Yeah, divide it by 2. You get x is how much then? Oh no, you got a decimal. Oh no. Is that okay? Yeah. Now, like you were worrying about for a second there, Kleckner, this is 111. That's 111. What's 111 and 111? 22. So I have 222 and 80 is how much? 302. How many degrees are left for down here then? 58, because there's going to be 360 in these figures, because there's 4 sides. What is this? This is weird. I want to show you a shortcut real quick. See if you can figure this out. No, I don't know if you need to draw it, because when you're dealing with mid-segments, sometimes when you have mid-segments like that, sometimes you don't have to write the formula completely. For example, whenever you have a mid-segment setup and you have 2 sets of numbers out of the 3, just figure out what the third one is. Here's what I mean. From 43 to 32, do you go up or down? Down. How many? 11. So what's 11 less than 32? So that other segment there, the other base, has to equal 21. What I'm getting at here is sometimes you don't have to do as much math. Whereas all I was doing was this. I know that 32 is the mid-segment. It has to equal half the sum of the 2 bases. And what I did is I doubled the other side. Subtracted the 43. But I did all that work out loud. That's why I wrote it out. I had some problems. I don't know if I posted them or not. I don't think I did. Yeah, no, time flies when you're having fun, right? In this one here on, what is this, 6-6. Yeah, can you write this out real quick? Yeah, I'll have it on mine here in a minute. It's a ton of problems that are just like the ones we were doing. Some mid-segment stuff, some angle stuff. There is one of them, I think it's the last one, that you'll have to actually think and use your brain for. But other than that, they're pretty quick. All right. Go back to the other one? Yeah. Can I go back to the other one real quick? I know it's up you're finished right now. Good. Go back to which one? You just don't go back.